Okay, so one of the things that we're learning today is old, and you guys are really good at it, I would say, because you've done it so much. The other one, I guarantee learn it, because y'all are honors class, but you probably didn't utilize it that much, so we're going to do that today as well. All right, so real simple day, I think. You're going to have probably like 10 to 15 minutes to work on your homework assignment. A lot of y'all might be able to finish it. So what we're talking about is Pythagorean theorem into our trig functions. Pythagorean theorem, that's the one that's just K for you guys, right? What is the Pythagorean theorem for? Well, it doesn't always just have to find the hypotenuse. It's just finding a side in a what? In a right triangle. Now, I might need to find the hypotenuse, which, again, I think y'all are all very familiar with. We'll talk about that. Or it could be finding one of the legs. But to use Pythagorean theorem, you have to have two of the three sides to find the third one. Okay? You have to have two to find the third. What two you have doesn't matter, but you need to have two to find the third. So what is that formula? Listen, y'all. See? Y'all know this. This is very familiar. So a couple things real quickly about it. One, it's a right triangle, correct? That means one of the angles has to be a what? 90 degrees. Now, if a triangle is made up of 180 degrees and 90 of them are gone, how much is left? 90. So two angles have to add to equal 90. So if they have to add to equal 90, they're both going to be less than 90, and therefore we refer to them as what kind of angles? Starts with A and ends in Q. Very good. Acute. It's an acute angle. All right. It could be 1 and 89, but they're still going to be acute. Okay? So, second thing. It's got to have 190-degree angle. So the first thing that you actually look for is the fact that across from the 90-degree angle is the side that we call the what? What do we call it? Across from the 90. We call that the hypotenuse. The hypotenuse has to be across from the 90-degree angle. What else does it have to be? It has to be the longest side. Has to be. Therefore, since it has to be the longest side, in the Pythagorean theorem, it has to be the value that we put where? Well, if one side is taking a squared and b squared and adding them, in order to equal the c squared, hypotenuse has to be placed where? It has to be placed in c's position. It has to be. Okay, no exception to that rule. The hypotenuse has to be c. Okay? The other two sides, we call them what? In a right triangle, the two sides that form that 90-degree angle, what do we call them? We call them legs. That's a leg, and that's a leg. So two sides are called the legs of that right triangle, and the other side is called the hypotenuse. It's across from the 90-degree angle. It has to be C. So let's use that Pythagorean theorem to find a missing side. So immediately I look at this right triangle number 1. I locate the 90-degree angle because across from that is my what? So what am I plugging into C's position? I'm plugging X in. Now, does it matter what I put as A and B? Could I put 4 as A and 8 as B? Could I put 8 as A and 4 as B? That doesn't matter. Okay, where my legs go doesn't matter. Are you with me back there? Really? I feel like you're struggling to be with me. So, my two legs, I'm going to use 4 first, because it's smaller. That's the only reason. Plus 8 squared. 4 squared plus 8 squared equals x squared. So I'm going to go straight to my calculator, type in 4 squared plus 8 squared. Tell me what you get. 80. So 80 equals x squared. How do I get x alone? We take the square root. Check and see if that's a perfect square. You probably already know that it's not. So we're going to break it down, and that's exactly right, Eugene. We're going to find the biggest perfect square that goes into 80. And the biggest perfect square that goes into 80 is 16. 16 goes in there. 5 times. Remember how we checked that? We divide 80 by 2, 40. I don't try a perfect square above 40. 36 won't work. 25 won't work. 16 does. 5 times. So the whole idea behind that is 16 being a perfect square gets to break out of that radical as a 4. The 5 does not. So my hypotenuse, simplified, is 4 square root of 5. 4 square root of 5. Easy, right? Y'all have done this a billion times. Maybe not a billion times. You've done it a bunch, right? You've done it a bunch. So we go over to number 2. Once again, it doesn't matter that my right triangle is kind of crooked. What's the first thing I want to recognize? What side is my hypotenuse? In this case, it is 24. So where does 24 go? In C's position. So I'm going to put 24 in C's position. 24 squared. Once again, I'm trying to find one of my legs. They've named it X. So I'm going to put it in A or B's position. I generally put the missing one in A's position. No big deal. So I'm going to do X squared plus 22 squared equals 24 squared. Okay? Now, I'm going to go to my calculator, save myself a little time. If you want to go ahead and type 22 squared and simplify that, and then type 24 squared and simplify that, you can. But I go ahead and just do 24 squared minus 22 squared. Go ahead and get X squared alone. Subtract 22 squared. 24 squared minus 22 squared is 92. Take the square root of 92. Is that a perfect square? No. So I'm going to break it down to, yep, 4. 4. If you try them, okay, 46 is what 92 divided by 2 is. 36 won't work. 25 won't work. 16 won't work. 9 won't work. 4 is the first perfect square that works, and it goes in there 23 times. So my simplified value for X for this leg is 4 comes out as a 2 times the square root of 23. So this leg is 2 square root of 23. Now, we start with Pythagorean theorem because in order to do these trig functions that we're about to talk about, that you probably have learned before in the past, you've got to know all 3 sides today in order to write these trig functions. Now, soon, we're going to use trig, actually, in order to find sides or angles that are missing. You see, Pythagorean theorem, it'll help me find a side if I'm given 2 sides, right? But will it tell me what the angles of that triangle are? No. That's where trig comes into play. Trig allows me to find missing sides or missing acute angles in a right triangle. Okay? So the first thing I need you guys to understand is when we do these trig ratios, we are doing them from one of the acute angles. And they usually identify the specific angle they want you to come from using this little sideways, I don't know. I've been calling it like a sideways, like an italicized Easter egg. But the real name for that is the Greek letter theta. Y'all see the italicized Easter egg? You know, you go Easter egg hunting and you can crack those eggs open. Kind of looks like that, but it's just crooked. So it's an italicized Easter egg. We're getting close to Easter, so there it is. It's an italicized Easter egg. Now, that's theta. Okay? So, we have 3 main trig functions. Okay? 3 main trig functions, 3 minor. The 3 main are right smack dab in the middle of your calculator. What are they? Sine, cosine, and tangent. Sine, cosine, and tangent. Okay? Sine, cosine, and tangent. So, here's how we remember it. Somebody, I can't remember who it was, Kate Miller, in 4th period, when I said what it is, they came up with this crazy thing. Mine's real simple. Okay? To remember this, try to remember so, ka, toa. Okay? So, ka, toa. Anai, can you say that? Say it. So, ka, toa.
I know a great way to remember it.
No, it's probably, I think it's probably the one that Caden said. He said it real fast, but it sounded inappropriate. But anyways. So, ka, toa. What? Soka is a bad word in your language?
In Russian.
Oh, in Russian. Yeah, and I just learned that you were at the Russian embassy school, right? Yeah, I saw that. Anyways, so, I'm sorry.
It's a really bad word.
Is it a really bad word? Well, goodness gracious. Oh, well, I'm not calling anybody that. Okay?
I can say my algebra teacher.
Y'all, probably shouldn't have told them that. They're going to start calling people that.
I can tell anyone.
Okay. Eugene, you're teaching these kids how to say bad words to people without them knowing. It's not good. Alright, so here it is. So is S. And then O over H. That's so. Pause. I don't want to say a cuss word. Ka. Okay? Pause. So it wasn't a bad word. So ka, of course, is what? That's cosine, and it's going to be what? It's going to be adjacent over hypotenuse. And then safely, toa, tangent is opposite over adjacent.
I think you're remembering like that way. To remember it is a lot more inappropriate than the way we do it.
Well, not until Eugene was in the class.
I'm just saying, the way I was taught.
Yeah, see, that's the thing. That's
a lot less than.
Oh, it's not. It's a lot more to remember than saying
it's a lot
so.
less inappropriate than yours.
Only now. Okay, so look, if you say the whole thing together, yeah, it's fine.
You say toa.
It's safe. If we add toa at the end, Eugene, we're safe. You sound like you're saying. I'm gonna call your parents and tell them you're cussing.
No, I remember like that. So.
Gotta add that H. Okay. Alright, so look, guys. How many sides do I have?
Like,
Look at that right triangle. How many sides do I have? 3. But how many legs do I have? I only have 2 legs. Right? Because we have one that's going to be called the what no matter what? It's the hypotenuse. It's the one across from the 90-degree angle. So that's the hypotenuse no matter what. Forget it. It can't be included in the other 2 because it has to be the hypotenuse. You got me? Here's the point. When it comes to the other legs, only one leg touches the particular angle that they're referring to. Right? That red line is the only leg that touches that theta angle that we're referring to. Therefore, it is the adjacent leg. Okay? The leg that touches it is the adjacent leg. Are you with me on that? The leg that does not touch that acute angle at all, that is my opposite leg. Are you with me? That's how you need to remember. Listen, if I were to do this, and y'all bear with me, let's say I were to cancel that out and I put theta right here. What leg is now the opposite leg? The red one, right? And what leg is now the adjacent one? The green one. The hypotenuse remained the hypotenuse. So please understand, it's based on the leg that touches the specific angle that you are referring to. So since we're referring to this angle down here, the green one is opposite, the red one is the adjacent, and the hypotenuse is the hypotenuse. Okay? Now, so is sine opposite over hypotenuse. Opposite over hypotenuse. So, pause. Ka. Adjacent over hypotenuse. I have felt completely fine about what I've taught all day today until you got in here. Now I feel guilty.
You gotta think about that all day.
And for
And
the
then-
rest of your life.
Yes, because, you know.
You've been teaching kids
Sure.
how to
I'm sorry. And then finally, tangent, TOA, is opposite over adjacent. When you guys are taking the quiz over this, and y'all get to this, some of y'all will snicker. All right, so those are your majors, sine, cosine, tangent. Your minors are cosecant, secant, and cotangent. Now, to remember that, here's how I remember it. S and C go together, and C and S go together. They're inverses of each other. Of course, you have to be brain damaged not to remember that tangent goes with cotangent, right? I mean, that one's a no-brainer. So, I like to remember that S goes with C and C goes with S. So sine, which one is the inverse of sine? Cosecant. Now listen, to be the inverse, that means this. If sine is opposite over hypotenuse, what's cosecant? Hypotenuse over opposite. And then C goes with S. So cosine goes with secant. So if cosine is adjacent over hypotenuse, secant is, you got it. And then like I said, the no-brainer is tangent and cotangent. If tangent is opposite over adjacent, what is cotangent? All right. Now listen, does cosecant, secant, and cotangent even have a button in your calculator? No. So obviously the more important ones are sine, cosine, and tangent. There's really no right triangles that we can't solve without them. Okay? So, here we go. Now, bring it back what we started with. Hunter, I'm about to take that phone and smash it. What we started with. I can't write all of these fractions until I know all of my sides. So this is where Pythagorean theorem comes into play. So, for number 3, I should have marked the 90-degree angle. I forgot to do that on some of the homework problems too. We don't know which side. A leg or a hypotenuse? We don't know a hypotenuse. So I'm going to set up my problem. 16 squared plus 30 squared equals my hypotenuse squared. You can call it whatever variable you want. If you want to call it C, call it C. If you want to call it X, call it X. Doesn't matter, you still solve the same way. What's 16 squared plus 30 squared? In your calculator? 1,156 equals X squared. Again, how do we get X alone? We take the square root, and yes, please always check to see if it is a perfect square itself. Had somebody earlier was trying to break down a number instead of just checking to see if it was a perfect square, and it was. What is the square root of 1156? So my hypotenuse here equals 34. Everybody with me? So here we go. Do y'all see where theta is? We're coming from this angle right here. The one I highlighted, the one that has theta. So in reference to theta, what's 30? Adjacent leg. What's 16? Opposite leg. And of course 34 has to be my hypotenuse. So here we go. So, opposite. What did y'all say it was? Opposite. But what is opposite? 16 over hypotenuse? 34. Will 16 over 34 reduce? Let's do it. 8 over 17. So real simple. If sine is 8 over 17, what's cosecant?
7.
All right, that was easy. Cosine, adjacent, 30 over hypotenuse, 34. So 30 over 34 also reduces to what? So if cosine is 15 over 17, C goes with S, secant is, and then finally tangent. from theta, what's the opposite leg? 16 over from theta, what's your adjacent leg? 30. So 16 over 30, which reduces to 8 over 15. So if tangent is 8 over 13 or 8 over 15, what's cotangent? Done. Guys, that's how easy this can be. All right? Now, one more. There's one little trick to this, and I'm going to show you, and I'm going to tell you I don't really care, but anyhow. Again, the first thing I want you to recognize is what is my hypotenuse? So I am trying to find a leg this time. Call it whatever you want, put it wherever you want, except for C. We've already got that spot claimed by the hypotenuse, don't we? So I'm going to go x squared plus the square root of 13 squared. Which is just what, Jacob? It's just 13, right? The square root and the square cancel. So really it's 7 squared, 49 minus 13, which gives me what? 36. If you went to your calculator and just typed in 7 squared minus the square root of 13 squared, it'll do that. So we take the square root of both sides, and sure enough, my other leg, my missing leg, is 6. Guys, use some logical sense. Let's say we did this wrong, and you end up getting that that leg was 12. Would you write 12 down? Or would you think to yourself, I may have made a mistake? Because remember what Jacob said earlier? The hypotenuse has to be the what? It has to be the longest leg. So if you come up with something that's longer than it, longer than 7, you've done something wrong. Okay? So just think logically when you do these. All right? So here we go. Here's theta. It just changed positions. That's fine. But we're going from this spot up here. Stop that. We're going from that spot right there. Here we go. From that spot, from theta. So, sine is opposite. What's opposite? 6 over hypotenuse, 7. So sine is 6 over 7, which won't reduce. What's cosecant? Easy. Cosine, A over H. Adjacent over hypotenuse. So for secant, I flip it, and it's 7 over the square root of 13. Yeah, I'm going to explain that one in just a second. Because I really personally don't care. I don't care. Let me explain it, okay?
Multiply both sides by square root of 13 and we will get
Right. I'll explain that in just a second. Let me go ahead and finish all these up, and then I'll go back and talk about that. Because you're right. But me personally, I just don't see. I'll get back to it. Last one, tangent. What's the opposite leg? 6 over the adjacent leg. Let's flip them to do our cotangent, square root of 13 over 6. Okay, back to what Eugene was saying. She's exactly right. Let's say you're taking a multiple choice test, ACT, EOC, whatever it is, and it asks you what the secant of theta is on this problem. Would you expect to see 7 over square root of 13 as one of your answers? No. Math, for some reason, hates having radicals in the denominator. Now, my personal opinion is I don't see why it's a big deal, personally. But on your test, you won't see 7 over square root of 13 as your secant of theta. You won't see 6 over the square root of 13 as your tangent of theta. They hate having radicals in the denominator. I don't know who they is, but they hate it. So what they do is they do this thing called rationalizing the denominator. Now let me explain what rationalizing the denominator does. If I had 1/2, y'all know the value of 1/2, don't you? If I multiplied 1/2 by 4 over 4, technically what am I multiplying by? I'm multiplying by 1, right? Y'all all agree that 4 over 4 is 1. Yeah. If I multiply 1/2 by 4 over 4, 1, I get 4 over 8. Now, does this 1/2 look identical to 4 over 8? No. One's 1 over 2, one's 4 over 8. They don't look identical, but they have the same value, right? They're both 0.5. That's the value. That's what you do to rationalize the denominator when you have a radical in it. You multiply by 1. But for example, on secant of theta, your 1 is square root of 13 over square root of 13. Because that's 1, isn't it? And I can multiply by 1 all day and never change the value. So even though square root of 13 over square root of 13 doesn't, look as easy as that, it's still 1. And here's what ends up happening. Up top, we just have 7 times the square root of 13. You can't multiply a number outside a radical by a number inside. Okay? But on the bottom, what happens to square root of 13 times square root of 13? It's technically square root of 13 squared, and what does square root and square do? And that's what allows it to break out of the radical, and now I have no more radical in the denominator. Now, because I don't care, I would have accepted this or this, okay? Because I just don't see the point, and here's the other point. If you're taking a multiple choice test and you get 7 over square root of 13 and you don't see it in your answers, what you should do is just type it into your calculator. Get the decimal value and then go to your answers, type those in your calculator. It should have the same what? Should have the same value. You understand? That's why I don't worry if y'all don't rationalize the denominator. But technically, the correct answer for secant of theta is 7 square root of 13 over 13. And most of you guys are so smart, you get in the hang of just looking at tangent of theta, for example, and you know the answer is what? 6 square root of 13 over 13. See? You just multiplied the top and the bottom by square root of 13, and it canceled it out of that radical on the bottom. That's it. So I don't care whether you do this and leave it or this and leave it. For me, I'm fine with both. Okay? Rationalize it, don't rationalize it. I'm not going to worry for my homework or quizzes or tests. Okay? All right. So that's it. You got 6 problems tomorrow, but I want you to listen to me. Tomorrow, you need to bring back this note sheet and homework, obviously, and Monday night's homework. Tomorrow night, we're going to do the back of that note sheet, and then we're also going to go back to what we did on Monday. And you remember that little section we didn't finish? You had to know the Pythagorean theorem to do that, which I know y'all knew the Pythagorean theorem, but it seemed pointless to do it before we did Pythagorean theorem. So we're going to go back and do that tomorrow, and that will be the lesson tomorrow, okay? Then on Friday we're going to use Trig. We're going to figure some stuff out because we know Trig. We know so, pause, ka, toa.
Now on.
I have to pause.
What about all those kids who taught that term?
They don't know what the bad word is. Ignorance is bliss.
Okay, but what if they get arrested?
Then they're going to cuss some dude out when they're talking about trigonometry.
They don't even care. Obviously, they're going to talk to someone. Yeah, why would they talk about trigonometry?
Hey, it's a topic. It's obviously a popular topic over at
Because
Lexington.
you're learning backwards. I think it helps you. It works with it.
Thank you.
Imagine the poor, Russian teachers having to teach.
Oh,
Yeah.
They
probably have to go
Well,
no, because I imagine
Well, they probably have to.
scientists.
Okay.
Right?
We'll put this on your desk.
Because they're going
What's the like?
We're going to knock out real quick. Yeah. Wait, what do you do?
No.
Yeah.
Sine is the opposite of the case. Look out for the rest of the Jacob, you can figure it out.
Well, those four, you're gonna need math.